Hello, and welcome to another installment of Mr. Marcus Math. We're going to graph some quadratics today, so we're stepping up our game. You guys ready? Hope so. So, here we go. We're going to graph some quadratic functions. Let's see here. How do we do that? Okay. So, here we go. Let's take, first what I want to do is I want to take this equation here. Let me move this real quick out of my way. You don't see what I'm doing, but I am doing something. All right, we're going to want to find the vertex of this parabola. So this thing looks like this, yeah? What I'm going to do is I'm going to try to find the vertex, its minimum or its maximum point. In this case, our parabola is actually going to open downwards because this is a negative. The a value is negative here. So I'm looking for the maximum value. So I'm going to do that first by finding the axis of symmetry, and that occurs at the opposite of b over 2a. So I know that a is -1, -1, b is -2, and c is 3. That's going to come in later for our y-intercept. So if I plug that in, the opposite of b is the opposite of -2 divided by 2a's. So I'm taking the opposite of -2, that's 2, and dividing it by -2. So I got x equals -1. That's my axis of symmetry. So that is the line that is going to split our parabola in half. Our vertex is on this line somewhere. So if I know that our vertex is on this line, I know that the vertex has to be -1 comma something. So I'm going to take the equation, and instead of x, I'm going to put -1. To find the y-coordinate. So plug in -1 here, plug in -1, and I get -1 squared is 1, but the negative sign is just waiting for it, so it turns it into a negative. -2 times -1, positive 2, plus 3. So I get y equals -1 plus 2, which is 1, plus 3 is 4. So our vertex, getting real sloppy already. All right, try to straighten it up here. Is at 1, -4. We should have already known that it's at 1 and then 4, 1 positive 4, 1 and up 1, 2, 3, 4. Here's our vertex. All right, there we go. Now it's opening downwards. Let's find the y-intercept. Let's find the y-intercept. Nice and easy. What I know is that it's where x is 0. So it occurs, this y-intercept is going to occur when x is 0. So I'm going to plug in 0 for all my x's. If I plug in 0 here, that makes that term 0. 0 here, -2 times 0 is 0, plus 3. So it's going to be here, right here at 3. Easy enough. That's the easiest thing we're going to do all day. So plot that point at 3. So 1, 2, 3. Since it's a mirror image of itself, I'm going to plot this point on the other side of the axis of symmetry. All right. Now let's find our x-intercept. Well, our x-intercepts. Looks like it's going to happen twice. What I know about my x-intercepts is that those occur when y is 0. So let's plug in 0 for y, plug in 0 for y, and solve for x. First thing I'm going to do is I'm going to look to factor this. I'm going to look to factor out a -1. So our a value becomes positive. We're left with x squared plus 2x's minus 3. So I'm now going to factor this guy. And x times x is going to make an x squared. I'm looking for two numbers that multiply to make 3 and subtract to make 2x's. So, well, 3 and 1. are the only way I know how to make 3, using integers. So 3 and 1, they need to subtract to make positive 2. So that looks like positive 2 minus 1. All right, so that's negative 1x, that's plus 3x's, that makes positive 2. So now what would the value of x be that would make the whole right side equal to 0? Well, if x was negative 3, that would make this factor 0, and 0 times anything is 0. Or x could be 1. So I know that x could be negative 3 or x could be 1. So those are our two, those are our x-intercepts. Right there. So let's plot those. Negative 3, 0, 1, 2, 3, and 1, 0. All we got to do is connect our lines now. Nice smooth curve. Bada bing. Bada boom. And there you have it. That is the graph of the function y equals negative x squared minus 2x plus 3.